Welcome to this tutorial video, which is dedicated to the procedure that the user has to follow in order to create a new application with Creo HMI. So, as usual, we will start from the home page of Creo HMI. So, the engineer has to select the Create New option, and a wizard will be opened that will follow the, let's say, step-by-step procedure in order to create a new application. So the first step is define the project name, the project author, and the folder where the project will be saved. By clicking the next button, we go to the next page where the user can select which is the target device where the application will be downloaded. Here we have the complete list of the families of the ISA devices, starting from the simple 7 inches HMI up to the iPC, Book PC or Box PC. For example, we can select the 15 inches HMI. On the right side, the user can select if the application will be developed for a landscape or portrait mode. Okay? By default, the application will be in landscape mode. Selecting vertical layout, the application will be in portrait mode. Press next. Here we have to select which are the communication driver to be loaded inside the application. The communication driver obviously will depend on the real controller that will be connected to the ISA device, let's say. By pressing Add Device button, here we have the complete portfolio of communication driver divided by the producer. For example, Allen Bradley, Siemens, Modbus, Panasonic, and so on. For example, we can select a standard Modbus driver, master protocol. In this case, the ISA HMI will be the Modbus master device. By pressing OK, we have added the Modbus TCP master protocol. In case the user will have to connect several slaves, it is enough to add a second instance of the same driver. So, for example, Modbus TCP. Each of these instances will be used in order to exchange the data with one of the slaves that will be connected. For example, by clicking on the first driver, we can change the name to slave 01, and then selecting parameter, we can define the communication parameter per that specific device. For example, the IP address will be 192.168.10.1. The communication port 502, it's the Modbus default port, and the Modbus address 1, for example. By clicking on the second device, we can define the name, so slave 02, okay. Parameter, the IP address of the second device, the communication port, and the slave address, which will be 2, and so on. Okay. Press done. The wizard is completed, and we have the first page of the application, which is obviously empty, totally empty. By double-clicking on the page, we have the possibility of adding some very basic object. So, for example, let's suppose we want to add a text. We can go up, select text, select an area on the page, and here on the right side we have the properties. So, for example, we can change the name to page 01, and we can define some, let's say, graphical properties. So, for example, enable the border and define a color, for example, yellow. Okay, this is a, let's say, a fixed text that will be put on top of the page. Next step is defining the communication variable, so the data memory point. We have to go to tags, okay, tag section. Actually, we don't have any data point, but we can create one. For example, add a new tag. We can put the tag name, so for example, I don't know, frequency 01. the address type, so it means that the tag, where the tag is mapped. So for example, device means that the tag is mapped over the external devices which are connected to the HMI. The type of the tag, so for example, unsigned integer. The slave where the tag is mapped. So based on the communication driver we have selected in the wizard, here we can select which is the controller where the tag will be mapped. So for example, slave 01, okay? The data area. Function code, for example, 0306, which is the Modbus function code dedicated to reading and writing a single register, a single holding register. On the right side we have the different data type, and here below the physical address. In case of Modbus, it goes from 0 up to 65K. This part of the tag window is specific of the communication driver that is selected. This is, for example, the window that is displayed in case of Modbus TCP. Okay, so we have the tag which is named frequency 01. Then we can go back to the page, and let's suppose here on the right side we want to display the value of this tag. So simply we can select the edit box, and here in the properties we can select in the tag property the name of the tag that we want to be displayed here in this position. We can also define, for example, the text format, so how many digits will be displayed, the format, the unit, and so on. Okay, now the last step is to display the same value via a meter object from the library. So we can go on the right side, select the library window, select graphic object, and which graphic object library we want to use, for example, black gray. Okay, we go to the meter section, we drag and drop the meter into the page, and then we go to the property, and in the tag property, as usual, select the same tag, frequency 01. So actually we have two different objects. The first object is a numeric field here, which is mapped over frequency 01, and the second object is this meter mapped over frequency 01. Now, in order to test what we have done up to now, we can run the offline simulation, so run project. It means that we don't need to connect the real controller because the communication will be simulated via a let's say fake driver. Okay, now the page is starting. You can see that the page will start in the browser. Okay, we have the demo window, and here we have the result of the application, so what will be displayed on the ESA controller, on the ESA HMI or IPC. If we change the value of the tag via the meter, you can see that the same value will be displayed here in the numeric field. And at the same time, if we modify the value here in the numeric field, in the meter itself, the same value will be displayed. So the result will be a simple project with one page, a text, a fixed text, and a numeric field and meter mapped over the same tag.